Welcome back to the second part of the pun tutorial. So this time we will talk about syncing objects through network. Last time I showed you how you can connect to the master and how you can join a random room. Before we start, a few things up front. So in the Photon server settings, you can set the pun logging to full if you want to have more of a deep insight into the pun engine and see all the logs that are created. In the network connection manager, we change a few things. On start, we say do not destroy on load, because our game object and connection manager shouldn't be destroyed when we switch from the menu scene to the network scene. And we say button connect master and connect room shouldn't be used here or set active or inactive if we have no reference to them. And the last thing, we disable the automatically sync scene because this causes some problems. As soon as the master is in network and the client connects, then the Photon framework actually changes the scene, and we do this by ourselves in the onJoinRoom method. So our player prefab right now is in the player folder. The problem is Photon does not work if we don't have a prefab in the resources folder. So we can have any resources folder anywhere in the tree. The important thing is that there is one or more resources folder and all the prefabs are in it. So I drag and drop it here, and this folder is now accessible for Photon. And there was a small bug in controller. We just say get component for the player because we want the player script on the same game object as the controller. Now we can start right away. So the player shouldn't be in the scene up front. We want to create the player via script as soon as one player joins the room. So the player script is or the game object with the player script is the thing we want to synchronize. So we change the money behavior to money behavior pun. We are adding the using statement, and then we are good to go. So basically it's still a money behavior, but there's one component called Photon view. And here is an example where you will actually use Photon view. So here I type Photon view is mine. And this is true if I was the creator of the object, because as soon as one component creates an object or instantiates an object, it will go through the complete room, and everywhere on every instance this object is created. But mine is only true for one client, and this is a client who creates this game object. So, and if we check if we have a controller, and it is not mine, then the controller should be destroyed. So for every player that is instantiated and not instantiated by myself, we will destroy the controller because we can't control the player then. The next thing in our player script is we will have a method called refresh instance. So this is a complete method. We will get a player reference and the prefab of the player. And the first time the player reference will be 0 and we will create it. And in other times, if the player is already set, we will destroy it and recreate it. So the position and rotation will be 0 then. And if the player is not null, then we will override the position and the rotation with the current player and then destroy the player. And directly after it, we will create it. We do not use game object destroy or game object instantiate. Instead, we use photon network destroy and photon network instantiate. It basically works like game object destroy and instantiate, but this will propagate it through the network and will be destroyed on every client and will be instantiated on every client. So we will just create the instant with a prefab. We do not pass the complete prefab as in game object instantiate. We will pass the prefab name, and Unity will have a look in all the resources folder and search for this exact name. So do have a unique name for every prefab, and then apply the position and the rotation. And after that, it just returns the game object, and then we can say get component player, and then we have our player here and give it back to the caller. Does this work right away? No. As a Photon view, we used, for example, to say photon view is mine, is null. So we actually have to add it here. So I've added the photon view. The owner is set at runtime. The owner is always the creator. You can change it, but we won't talk about this in this tutorial. The owner is always the creator at the beginning. It will be set at runtime. The view ID is a unique ID, and this ID is unique in the room. For example, there is an ID with 1, 2, 3, and every client will have one instance with this view ID. And if a game object is destroyed, for example, a game object with ID 1, 2, 3, it will be propagated through the network, and every view or game object with this view will be destroyed. The most important thing is the observe option. If it's off, it's not synchronized. So we would change unreliable on change. This means as soon as one of the observed values change, we will send an update. An unreliable update, this means it could be that this change isn't propagated, but it doesn't matter. For example, we will take the position, and if the position is not propagated yet, the next update will override it automatically. Now we come to observed components. This will appear here, and then we have some options. So you can just type photon as a component, and you see all the components, and everything that enters in view, except the photon view, of course, you can use to automatically propagate all the changes. For example, a rigid body view or a transform view. And then you can check just what you want to synchronize. For example, we want to synchronize the velocity and synchronize the position and rotation, not the scale. And we just have to drag and drop these components here. We can add new ones. And there we go. The rigid body and the transform will be propagated. Okay, we have a method called refresh instance on the player, but it's called nowhere. So if we start the scene, no instance will be there. Therefore, we create a game manager. So we have a game manager object, and then we create a game manager script. For example, this simple script, the game manager, and it inherits from mono behavior pun callbacks and has just a player prefab. So we have used mono behavior pun, then we have the photon view, which we can access. If we have the callbacks, remember we will have the functions or methods we can override. And if you just type override and on, you will see all the methods you can override. And we will use on player entered rooms. This is called when an enemy or yourself enters a room. And you have to use this namespace Underdog City because Photon really use very generic names like game manager and player as well. And to differentiate between those two, it's good to have a namespace, then you will have no conflicts. So we will call the base class, and then we will say player refresh instance reference to the local player and the player prefab. We do not have the local player yet, so let's add it here, local player, and there we go. As soon as the player enters the room, we will refresh our local instance, because if a player enters the room, the old instances that are already created aren't recreated on as soon as the player enters the room. Everyone has to say, okay, I have instantiated this one, and this one, and destroy the old one first. To be sure that the player is really created, we will also call this on start. And on awake, we will just check if we are connected, then everything is fine. If we are not connected, then we have to load the scene menu. So if you want to add the game manager, you will find it 2 times, because one time it's from the demo scene of Photon. They already have a game manager, and once is yours. So make sure that you really got yours. So if I choose the first one, I see directly this is mine because it says tutorial game manager, and I can set the player prefab here to have the script ready. So now I will build the scene because I want to have 2 instances. As soon as you build your scene, you can double click on your game and start it. I have to rebuild it because the menu has to be the first and the network the second. So the first one is always started. This is how it should look like. You start your editor, and if you are in the network scene, it automatically switches to the menu because we have specified this in the game manager. And when you start your game, you should always see the same screen. So we connect to the master and then we can click on join room. The first one who clicks join room is the master. So I want the Unity editor to be the master. So I click join room and then on the external window. And there we go. You see already an error message here in this console. This is the development console from the build. But you see it's working. So the position and rotation is somehow transferred over the network. The velocity as well, so it looks pretty good. I could even jump, but all the animation isn't right, so it looks a little bit weird. And this is because we do not transfer our input, and our input is necessary to have the right animations. So the next thing is to synchronize our input, not only our position. Our input is here in the player, so we can just send this input and we are good to go. To do this, we have to add an interface, the ipon observable, and then we implement this interface and we get a new method on photon serialize view. This is called 2 times. One time is when another player sends update and we have to apply the changes, or when Unity or Photon ask for the current values that should be sent to others. So we have to say if stream is writing, then we will write, and the else is stream is reading. So if the stream is writing, we just send the one x, one z, look x, and z, look z value. And if the stream is reading, we will receive all the things and apply this to these values. So some of you might say, okay, if I just want to send one value, I could just send the input. It looks fine here, but Photon can't serialize any structure. So it can only serialize float values like these 4, booleans, integer, and very, very basic values. I don't know if they can handle vector 3 values or something like that. You will be always safe if you're using floats. So we just say stream, send next, float, float, float. And if we read the stream, they will be in the same sequence as we write them to. So the first one is the 1x, 1z, look x. So you should imagine that this is player 1 and it sent its current input, and this is player 2 in the room, and it will receive the input and can display the data. We're not done yet. We have to go to the player and add an observed component. Here we already have the widget body and the transform, and now we can add the player. And for example, we can't use the controller because it does not have the interface, but the player has the interface. So we could also say, okay, we can get rid of the position, rotation, and so on. So we could delete those two and do it by our own, by just say, for example, stream, send next, transform, position x, and y and z and so on, and just apply them here. And then we have done everything we need for the position, and we can just delete the transform view. But I wanted to show you that there is some kind of pre-configured observed components that you can use, and everything that is missing and that you still want to have in sync, you can add it to the on serialize view. And this time it looks way better. You see the character here on this player screen is actually animated. We can jump, we can run around. It has some kind of a little lag, but this is how networking is working. So you have to interpolate values and something like that to make it really smooth. To keep it simple, we will stay like this. And maybe in the next tutorial I will show you how you actually can smooth out these values so that it doesn't look so laggy as you can see here. But that's basically it. You can have a look down into the description. There is a modified player script and the game manager scripts that you can look everything up and have a look into all of the scripts. Make sure to subscribe, because the next episode will have also some basic components of the photon network, and the third part really closes up all the 3 parts. See you then.